Two common applications of stoichiometry are percent yield calculations and determining limiting reagents. Most of you probably saw the percent yield concept and calculation in Chem 1, but some of you didn't see the limiting reagent calculations. I'm going to go over both of these in this video. Percent yield is a description of how much product is actually collected during a lab procedure compared to the maximum amount that could possibly form from the amount of reactant that was provided. Here's the mathematical equation. Actual yield is how much was actually collected when the procedure was performed. Theoretical yield is the amount that should form based on the amount of reactant given. To calculate percent yield, you divide actual by theoretical and multiply by 100. Here's a percent yield question. When 55.6 grams of hydrogen reacts, 159 grams of NH3 are produced. To calculate the percent yield, we need an actual yield and a theoretical yield. Only one of those is explicitly given to us in the question. 159 grams of NH3 is the actual yield here. That's the amount of product the question says was actually collected. 55.6 grams of H2 is how much reactant was put in. What we have to do is use that amount of reactant to calculate a theoretical yield. If all of that reactant became product, how much would it be? So we use stoichiometry to convert from 55.6 grams of H2 to grams of the product NH3. So I'll start with my given number of 55.6 grams of hydrogen. I'm going to convert from grams to moles. Then I'm going to convert from moles of that reactant to moles of the product. And now I need grams of my product. I need to compare apples to apples. If I know grams of the product that actually formed, I need to know the grams of the product that should theoretically form. So I have one more conversion to make here. Solving here, I get 313 grams of NH3. That is the theoretical yield for this process. Now we can calculate the percent yield. We'll put the actual yield on top. That was given in the question as 159 grams. Divided by the theoretical yield that we just calculated of 313 grams times 100, and the percent yield here is 50.8%. Now let's talk about limiting a reagent. First of all, reagent is just an old word for reactant. So limiting reagent means the reactant that limits the progress of the reaction. When any one reactant runs out, a reaction stops. So limiting reagent is the reactant that runs out first. Let me use an analogy first to explain this. Let's say we work in a factory that assembles teddy bears. Here's all the components needed to make our teddy bears. We would need one body, one head, 2 ears, 2 eyes, 1 nose, 2 arms, 2 legs, 1 bow, and stuffing. And let's say we have these amounts on hand. How many teddy bears can we make? With 50 bodies, we can make 50 bears. With 50 heads, we can make 50 bears. With 500 ears, we could make 250 bears, and so on. Which of these numbers limits how many bears can be made? It's 50 legs. 50 legs means we can only make 25 bears. After that, we have no legs left, and you can't make a whole teddy bear without any legs to sew on. So the number of legs limits our process. That's exactly what a limiting reagent is in a chemical reaction. It's the reactant that runs out first and it stops the process. Here's a real chemistry example. It says a mixture of 1.20 grams of H2 and 7.45 grams of CO are allowed to react according to the reaction given. Notice that this question gives you amounts for both reactants. That immediately tells you that you'll need to determine the limiting reagent. One of these two reactants will run out first and the reaction will stop. That's your limiting reagent. The way to find the limiting reagent is to calculate how much product you can get from each of these reactant amounts individually. So start with 1.20 grams of H2 and calculate the amount of CH3OH, that's methyl alcohol, that can form. Then start with 7.45 grams of CO and calculate how much methyl alcohol can form from that. Starting with the grams of hydrogen, I'm going to convert 1.20 grams of hydrogen first to moles of hydrogen, then to moles of methyl alcohol. This one comes out to 0.298 moles of product. Now I'm going to do the same thing again using the grams of CO given in the question. Using carbon monoxide's molar mass, I'll convert to moles, and then I'll convert from moles of carbon monoxide to moles of methyl alcohol. This equals 0.266 moles of product. You can convert to moles of methyl alcohol, or you can continue on and calculate grams. All that matters is that you remain consistent. If you stop at moles in the first calculation, stop at moles in the second calculation too. So when we finish these two calculations, the grams of H2 that was given in the question, we find can produce 0.298 moles worth of product. The grams of CO given in the question can produce 0.266 moles of product. Obviously, 0.266 moles is the smaller amount of the two. So when 0.266 moles of methyl alcohol has been formed, all the CO has reacted, so the reaction has to stop. We can't make 0.298 moles of product here because we don't have enough CO to get there. That means CO is our limiting reagent. H2 is called the excess reagent. When this reaction has stopped, there would still be some H2 present that never reacted because it had nothing left to react with. When you answer a question like this on paper for a quiz or a test, make sure that in addition to the calculations that we just looked at, you actually write down the phrase, blank is the limiting reagent. So in this example, that means you need to actually write down CO is the limiting reagent. You can abbreviate with LR if you want to, but you have to have that phrase on your piece of paper to get full credit for a question like this. Just showing me the calculations, underlining a couple things, circling a couple things, doesn't prove to me that you know the chemistry of what you've done. You have to write this down to get full credit. Now the second question asks, how many grams of methyl alcohol are produced? We already figured out that carbon monoxide is our limiting reagent, and it produces 0.266 moles of methyl alcohol. So all we have to do now is convert that number of moles of methyl alcohol to grams. This is a very common follow-up question after determining a limiting reagent. Make sure that you always use the amount of product formed from the limiting reagent to answer the question. Remember on that previous slide that our calculation said that the amount of H2 in the question could produce 0.298 moles of methyl alcohol. But in reality, that amount of product can't form here because CO limits the reaction. That's the whole point of limiting reagent. So you have to start this question with the amount of product that can form from the limiting reagent. The final question here wants you to calculate the amount of the excess reagent that is left over after the reaction stops. To do this, start with your limiting reagent amount, the 7.45 grams of CO here. From that, calculate the grams of the excess reagent that actually reacts during the process. So convert from grams of your limiting reagent to grams of your excess reagent. This number tells you how many grams of the excess reagent actually did react. If you know how much you started with, that was given back at the beginning of the question, 1.20 grams of H2 was provided, and now you know how much actually reacted, 1.07 grams of H2 reacted. You can calculate how much is left after the reaction stops by subtraction. So in this example, we find that there's 0.13 grams of H2 in excess.